Parametric curves. Start with definition. We say that the curve is given to us parametrically. Curve C is a parametric on a plane. If we have both x and y coordinate point are given to us as a function on t. So x is a function of t, f of t, and y is a function of t, g of t. Example. Say we have a parametric curve. Given by x equals to cosine t, y equals to sine t, and we have some restriction on t. We're just saying that t is bounded between 0 and 2 pi. Say we want to figure out what kind of curve is that. So determine firstly, what we'll do is we're going to substitute a couple values for t and figure out what the corresponding values for x and y. So we start with t, then we find corresponding values of x and y, and then we're going to plot the points on the xy plane, and then we connect points for hopefully continuous curve, and hopefully we'll be able to visualize what kind of curve we're going to see. So we start with t equals to 0, cosine of 0 is 1, sine of 0 is 0, so we have x equals to cosine of 0 is 1, y equals sine of 0 is 0, and we go pi over 2, x equals to cosine, so x equals to cosine of pi over 2 is 0, y equals to sine of pi over 2 is 1, and we go to the next one, t equals to pi, when t equals to pi, x equals to cosine of pi negative 1, y equals to sine of pi is 0, then we go to 3 pi over 2, going to cosine of 3 pi over 2 is 0, sine of 3 pi over 2 is negative 1, and we do one more point, t equals to 2 pi, x equals to 1, y equals to 0. Now we'll try to sketch the curve. So we start with t equals to 0, t equals to 0, x equals to 1, y equals to 0, t equals to pi over 2, x equals to 0, y equals to 1, at t equals to pi, x equals to 0, y equals to negative 1, at t equals to 3 pi over 2, x equals to 0, y equals to negative 1, so that is t equals to pi, that's t equals to 3 pi over 2, and at t equals to 2 pi, back where we started to a point when x equals to 1, y equals to 0, and we try to connect points, consecutive points, from t equals to 0 to t equals to pi over 2, from t equals pi over 2 to t equals to pi, from t equals to pi to 3 pi over 2, and that's what we got. And we also notice where we're going along this curve. Okay. So what we notice is, according to what we got, is we're expecting that that curve is probably a circle. Now let's confirm that it is. Now let's try to confirm this guess using some algebraic manipulations. Notice that x equals to cosine t, and notice that y equals to sine t. If you look at the cosine t and sine t, then almost immediately you want to think about main trig identity, which connects cosine and sine, and the main trig identity says cosine squared plus sine squared equals to 1. Then from here, you see that x cosine t, y is sine t. So we're going to substitute x for cosine t, y for sine t. So we're going to get x for cosine t, y for sine t. So we're going to get x squared plus y squared equals to 1. And that is exactly as we guessed before, circle of radius 1, center at origin.